March 12, 1941. Kure Naval Arsenal, Japan. Vice Admiral Fukuda Keiji examined the cross-section blueprints of Yamato's underwater protection system, his thick fingers tracing the complex arrangement of void spaces, liquid layers, and armor plates. His uniform bore 3 rows of campaign ribbons from victories in Manchuria and China. "Look at this," Fukuda said, tapping the diagram with dismissive satisfaction. "The Americans still rely on single-layer torpedo bulkheads while we have perfected the 4-layer system." Captain Matsumoto Hiroshi, chief naval constructor, nodded sharply. "Their newest battleships have 12.2 meters of underwater protection. Yamato has 16 meters. They cannot possibly penetrate this depth." Commander Yamato Takeishi, Naval Intelligence Section, leaned forward with carefully measured words. "Admiral, our agents report the Americans are testing new torpedo designs with significantly increased warhead sizes. Perhaps we should review the holding bulkhead thickness calculations." But Fukuda waved him off with a sound of contempt. "Their Mark 14 torpedo carries 292 kilograms of torpex. Our protection system is designed to withstand 400 kilograms detonating in direct contact. Mathematics, Commander, not speculation." At Coral Sea, Japanese carriers had achieved 4-1 aircraft losses favoring Japan. At the Java Sea, the Allied fleet suffered complete annihilation with 2,300 casualties against 36 Japanese dead. At Pearl Harbor, 8 battleships damaged or destroyed with 0 Japanese capital ship losses. The mathematics were undeniable. Japanese naval engineering represented the apex of maritime warfare design. What Fukuda didn't know, what none of them could have known as they reviewed those blueprints in that Arsenal conference room, was that American torpedo innovation would reduce Yamato's 16-meter protection system to irrelevance within 4 years. The numbers would become catastrophic. 386 American aircraft against 1 battleship, 3,055 Japanese dead, 11 torpedo hits. The confident approval in that conference room would become history's most expensive miscalculation, measured in the total loss of the world's largest battleship and nearly its entire crew. The confidence section. Vice Admiral Fukuda's certainty rested on irrefutable combat data spanning 3 years of Pacific warfare. At the Battle of the Java Sea, Allied cruisers HMS Exeter, HMS Encounter, and USS Pope were systematically destroyed with Japanese forces suffering 1 destroyer moderately damaged. Kill ratio, 13-0-2. At the Indian Ocean raid, Japanese carriers sank the British carrier HMS Hermes, 2 cruisers, and 2 destroyers without losing a single vessel. Kill ratio, 5-0. At Savo Island, 1 Japanese cruiser force sank 4 Allied heavy cruisers in 32 minutes of night combat. Kill ratio, 4-0. The pattern was mathematically consistent across every naval engagement from 1941 through 1943. Yamato's specifications existed beyond Allied capability to counter. Main battery, 9 46-centimeter guns, the largest naval rifles ever mounted on a warship, each shell weighing 1,460 kilograms with a maximum range of 42 kilometers. Secondary battery, 12 15.5-centimeter guns, 12 12.7-centimeter dual-purpose guns. Anti-aircraft armament, 24 25mm triple mounts, 4 13.2mm twin mounts. Belt armor, 410 millimeters of hardened steel, tapering to 200 millimeters at the lower edge. Deck armor, 230 millimeters across the citadel. Turret face plates, 650 millimeters. Underwater protection, 16 meters of layered void spaces, fuel oil compartments, and 75 millimeter holding bulkheads designed to contain and dissipate torpedo blast energy across multiple sacrificial zones. Displacement, 72,000 tons at full load. Maximum speed, 27 knots. Range, 7,200 nautical miles at 16 knots. No American battleship approached these specifications. American failures accumulated through 1942 and early 1943 validated Japanese confidence. The Mark 14 torpedo suffered a 60% failure rate from defective magnetic exploders through December 1943. At the Battle of Tassafaronga, American destroyers fired 20 torpedoes at Japanese destroyer transport force, achieving exactly 2 hits due to defective depth-keeping mechanisms and exploder failures. At Midway, torpedo bomber squadrons suffered 80% casualties delivering attacks that produced 0 hits from faulty ordnance. The Bureau of Ordnance refused to acknowledge systemic defects, until submarine commanders conducted unauthorized live-fire tests, proving the Mark 14's magnetic exploder, depth-keeping mechanism, and contact exploder all functioned effectively. American torpedo technology in 1943 represented a catastrophic industrial failure spanning 2 years of combat operations. Vice Admiral Fukuda had personally commanded heavy cruiser Takao during the Java Sea action, his ship firing 87 rounds of 20-centimeter armor-piercing ammunition to deliver the killing blow to HMS Exeter. He had observed American cruisers at Savo Island, absorbing dozens of hits before sinking, their damage control proving adequate but not exceptional. He had reviewed damage reports from Guadalcanal showing American vessels requiring weeks of repair for damaged Japanese ships sustained and corrected within days. His combat experience spanning 1,200 days of continuous operations confirmed what the blueprints promised. Japanese naval engineering had achieved material superiority that American industry could not overcome through numbers alone. The armor, the compartmentalization, the redundant systems, all proved superior under combat conditions. Commander Yamato had presented intelligence reports to the Naval General Staff on 3 occasions warning of American industrial mobilization. His February 1943 briefing detailed Liberty ship production, 140 vessels monthly from 18 shipyards, each yard producing more tonnage than Japan's entire merchant marine construction capacity. His May 1943 assessment documented Essex-class carrier production, 9 vessels under construction simultaneously across 4 yards, with completion times of 15–18 months from keel laying to commissioning. His September 1943 analysis detailed torpedo bomber production, Grumman producing 550 Avenger aircraft monthly from a single Long Island facility, more aircraft than Mitsubishi, Nakajima, and Kawanishi combined produced quarterly. The staff dismissed each report. American workers lack Japanese discipline and fighting spirit. Their production numbers reflect quantity without quality. 1 Japanese pilot equals 5 American pilots. 1 Japanese ship equals 3 American ships. The mathematics of morale and training supersede the mathematics of production. Yamato had documented his objections in writing. The Naval General Staff had filed his reports without action. Lieutenant Sato Kenji, torpedo defense officer aboard Yamato, had participated in damage control exercises simulating multiple torpedo hits against the protection system. The exercises validated design specifications. 1 simulated hit, flooding contained to void spaces and outer liquid layer, no penetration of holding bulkhead, no flooding of machinery spaces, sustained 27-knot maximum speed. 2 simulated hits, flooding contained to outer 2 layers, minor list corrected by counterflooding, sustained 25-knot speed. 3 simulated hits, flooding contained to outer 3 layers, moderate list corrected by counterflooding and pumping, sustained 22-knot speed. The holding bulkhead, 75 millimeters of hardened steel backed by structural reinforcement, represented the final barrier protecting machinery spaces from flooding. Design calculations demonstrated this bulkhead would contain blast effects from any existing torpedo warhead. Sato had supervised flooding drills across 400 compartments, timed damage control teams responding to simulated hits, verified pumping capacity, exceeded flooding rate projections by 40%. His experience afloat confirmed what his training ashore had promised. Yamato could sustain significant torpedo damage and continue fighting. The mathematics seemed irrefutable. American innovation. Pensacola, Florida, January 1943. Lieutenant Commander Charles Hamlin examined the test results from the most recent Mark 13 aerial torpedo trials, his oil-stained hands leaving fingerprints on the data sheets. The Naval Air Station Modification Facility produced 17 improved torpedoes daily. Every 8 hours, another batch of modified weapons rolled off the assembly line where workers had completely redesigned the wooden tail assembly, strengthened the nose structure, and replaced the problematic Mark 6 exploder with the reliable Mark 8 contact mechanism. This process was transforming American aerial torpedo reliability from 20% to 85% in 6 months. In January 1942, America produced just 120 aerial torpedoes monthly across 3 facilities with a failure rate exceeding 60% from multiple systemic defects, including nose collapse on water entry, tail section disintegration, exploder malfunction, and depth-keeping errors. By June 1943, production reached 890 torpedoes monthly across 7 facilities, with failure rates declining to 35% following initial exploder corrections. By December 1943, Pensacola's single modification facility was producing 510 improved Mark 13 torpedoes monthly, each weapon incorporating 47 specific design changes, addressing every identified failure mode. By March 1944, this single facility was producing more reliable aerial torpedoes than the entire Japanese torpedo production establishment had manufactured in 1943. Commander Yamato had documented this progression in his April 1944 intelligence assessment. The Naval General Staff dismissed his report as statistically improbable given American industrial disorganization. Margaret Harrison, previously a schoolteacher from Pensacola teaching algebra to 8th grade students, now operated the tail assembly jig, producing 94 wooden stabilizer units every 9-hour shift. She worked with 4 other women on the tail assembly line, their collective daily output of 470 stabilizers exceeding the monthly production of the entire Yokosuka Naval Arsenal torpedo facility. Each stabilizer required 23 precise measurements, 17 drilled holes positioned within 0.5 millimeter tolerance, and 11 bronze fittings installed with specific torque requirements. Margaret's team maintained 99.2% quality acceptance rates. She produced more torpedo components in one shift than Japan's primary torpedo facility produced in a week. Robert Washington, from Mobile, Alabama, operated the warhead assembly station that produced 17 complete warhead sections daily, each containing 270 kilograms of Torpex explosive compound. His single station's daily output of 4,590 kilograms of assembled torpedo warheads exceeded the entire monthly warhead production of the Kure Naval Arsenal. The assembly process required installing the Mark 8 contact exploder, positioning the booster charge, securing the arming mechanism, and conducting electrical continuity tests on 3 separate firing circuits. Washington's station maintained 98.7% first-pass acceptance rates. His individual productivity exceeded that of Kure Arsenal's entire 47-person warhead assembly section. James Mitchell, $1-a-year executive from Packard Motor Company, managed the exploder modification program that retrofitted 1,240 torpedoes monthly with reliable Mark 8 contact mechanisms, replacing the defective Mark 6 magnetic exploders. Mitchell had transferred Packard's automotive assembly line methodology to torpedo modification, creating a 17-station process where each weapon spent exactly 22 minutes per station for complete exploder replacement, testing, and verification. His facility processed more torpedoes through modification in one day than the Bureau of Ordnance had acknowledged as defective during the entire first year of war. Mitchell's assembly line proved that American industrial methodology could correct in months what Navy bureaucracy had denied for years. Americans discarded 340 kilograms of Torpex explosive daily from torpedoes that failed final acceptance testing, warheads that exhibited minor cosmetic defects, or weapons damaged during handling. Japan allocated 180 kilograms of torpedo explosive monthly to the entire Kure Naval Arsenal for new production. American torpedo facilities threw away in one day nearly twice what Japanese arsenals received for an entire month. The waste from single-day explosive rejection exceeded Japan's total monthly allocation for all torpedo production facilities combined. Workers threw away wooden tail assemblies that Japanese craftsmen would have carefully repaired and reinstalled. Tail assemblies showing minor warping, superficial cracks, or cosmetic damage went directly to scrap bins. Japan rationed wood for military use by the kilogram. The Pensacola facility discarded more wooden components daily than Japan allocated monthly to all naval arsenals. The cafeteria discarded more beef daily than the Yokosuka Naval Station received monthly for 8,000 personnel. Cafeteria waste from 1 week, measured at 1,240 kilograms of discarded food, including 180 kilograms of rejected meat, exceeded the monthly protein allocation to the entire Sasebo Naval District. The aluminum scrap from rejected torpedo body sections, measured at 890 kilograms daily, could have built 17 Japanese aircraft. Japanese industry allocated aluminum by the gram. American torpedo facilities threw away more aluminum in one day than Japan allocated monthly to Mitsubishi, Nakajima, and Kawanishi aircraft plants combined. Commander Yamato visited naval production facilities during his April 1944 intelligence assessment tour. He documented worker productivity metrics. American torpedo workers produced 8.7 weapons per worker monthly. Japanese torpedo workers produced 1.2 weapons per worker monthly. American facilities operated 3 8-hour shifts with meal breaks, Chinese letter, and workplace safety protocols. Japanese facilities operated 2 12-hour shifts with minimal breaks and increasing workplace accidents from exhaustion. American production increased monthly while Japanese production declined from raw material shortages, transportation disruptions, and worker attrition. Yamato calculated that American torpedo production would exceed Japanese production by 12:1 ratios by mid-1944. His report warned that numerical inferiority in torpedo inventory would become catastrophic regardless of individual weapon quality. The Naval General Staff noted his report and took no action. First contact. November 24, 1943. Rabaul Harbor, New Britain, 11:27 hours. Lieutenant Sato Kenji was supervising flooding drill exercises in Yamato's starboard torpedo protection compartments when the air raid alarm sounded across the harbor. He ordered his damage control teams to secure from drill and proceed to battle stations. At 11:29 hours, radar reported incoming aircraft at 82 kilometers, bearing 135 degrees, altitude 4,200 meters. At 11:31 hours, visual identification confirmed 90 American carrier aircraft approaching in 3 waves. Torpedo bombers low on the water at 30 meters altitude, dive bombers at 3,000 meters, fighters providing cover at 4,800 meters. The formation demonstrated coordination absent from earlier American attacks. At 11:34 hours, Yamato's anti-aircraft batteries opened fire at maximum range. 24 25mm triple mounts, 12 12.7 centimeter dual-purpose guns, and 4 13.2mm twin mounts created a defensive barrage firing 840 rounds per minute combined. At 11:35 hours, first American torpedo bomber destroyed at 3,200 meters range. Kill time 8 seconds from initial contact to aircraft disintegration. At 11:35 hours plus 23 seconds, second torpedo bomber destroyed at 2,800 meters. Kill time 6 seconds. At 11:36 hours, third torpedo bomber destroyed at 2,400 meters. Kill time 9 seconds. The leading torpedo bomber wave of 15 aircraft absorbed concentrated anti-aircraft fire for 90 seconds before reaching weapons release range. At 11:37 hours, surviving torpedo bombers released weapons. Visual tracking identified 7 torpedoes running toward Yamato at depths estimated between 4-6 meters. Yamato's captain ordered emergency turn to port, maximum rudder angle, flank speed to complicate torpedo targeting solutions. At 11:38 hours plus 12 seconds, first torpedo passed down the starboard side, missing by 18 meters. At 11:38 hours plus 34 seconds, second torpedo passed astern, missing by 23 meters. At 11:39 hours, third torpedo struck starboard side amidships, frame 140, detonating in contact with outer hull plating. The explosion delivered approximately 270 kilograms of torpex against the outer protection layer. The blast created a 6-meter hole in the outer hull, flooded the first void space, and collapsed the first liquid layer bulkhead. The second liquid layer bulkhead held. Flooding was contained to outer protection zones. No machinery space flooding occurred. Yamato's speed decreased from 27 knots to 25 knots temporarily during damage assessment, then returned to 26 knots after damage control teams confirmed containment. The protection system functioned exactly as designed. One torpedo hit produced manageable flooding contained by the second bulkhead layer. Lieutenant Sato's damage control teams required 17 minutes to complete flooding assessment, establish pumping operations, and verify structural integrity of remaining bulkheads. Total engagement duration, 12 minutes 40 seconds. Enemy losses, 11 torpedo bombers destroyed, 7 dive bombers destroyed, 3 fighters destroyed. Total, 21 aircraft destroyed, 63 American aircrew killed or captured. American losses exceeded 1/4 of attacking force. Japanese losses, 0 ships sunk, 1 battleship sustaining minor damage that would require 3 days dockyard repair. Kill ratio, 21-0. The ammunition expended in this 12-minute engagement, measured at 10,600 rounds of 25 mm, 340 rounds of 12.7 cm, and 180 rounds of 13.2 mm, exceeded the monthly ammunition allocation to the entire Truk Naval District. Sato observed that the single torpedo hit had produced exactly the flooding pattern predicted by design calculations. Yamato's protection system had performed perfectly. Vice Admiral Fukuda reviewed the action report aboard his flagship. 1 hit from 7 torpedoes. Their accuracy is appalling. Our anti-aircraft defenses destroyed 21 aircraft. This engagement validates every design decision we made. The Americans throw away pilots and aircraft achieving negligible results. He dismissed concerns about the coordinated attack pattern as fortunate timing, not tactical innovation. Escalation pattern. Intelligence dismissed the November 24 engagement reports as confirmation of existing American tactical deficiencies. Vice Admiral Fukuda chaired the Damage Assessment Review Board examining Yamato's torpedo protection performance. The protection system contained flooding to outer zones exactly as designed. 1 torpedo produced 180 tons of flooding. The holding bulkhead sustained 0 damage. These results prove American torpedoes cannot penetrate our underwater protection regardless of their numbers. The review board recommended no design modifications. The 4-layer protection system had functioned perfectly. American torpedoes lacked the warhead mass or explosive power to threaten holding bulkheads. The mathematics of blast propagation through layered defensive zones demonstrated that even simultaneous multiple hits would be contained by interior bulkheads before reaching vital machinery spaces. Commander Yamato reported to the Naval General Staff in December 1943 with updated intelligence on American aerial torpedo modifications. The Mark 13 torpedo has been completely redesigned. Wooden tail assemblies now withstand water entry impact at 180 knots. Nose strengthening prevents collapse on entry. The Mark 8 contact exploder demonstrates 85% reliability compared to previous 20% rates. American strike coordination has improved dramatically. The Rabaul attack demonstrated unprecedented timing precision between torpedo bomber, dive bomber, and fighter elements. Most significantly, American training cadence has accelerated. Carrier air groups complete workup cycles in 8 weeks compared to previous 16-week timelines. Yamato presented production comparisons. American torpedo bomber production exceeded 520 aircraft monthly. Japanese torpedo bomber production totaled 87 aircraft monthly. A single American Grumman facility on Long Island exceeded the combined monthly output of Mitsubishi, Nakajima, and Kawanishi. American torpedo production reached 890 weapons monthly. Japanese torpedo production totaled 240 weapons monthly. A single American modification facility at Pensacola produced more aerial torpedoes than Japan's 3 naval arsenals combined. The Naval General Staff listened to Yamato's briefing with visible impatience. Commander, your statistics neglect qualitative factors. American workers lack discipline. Their aircraft lack refinement. Their pilots lack fighting spirit. Our torpedoes rarely fail. Our pilots require half the training time to achieve superior proficiency. Our aircraft, while produced in smaller numbers, demonstrate superior performance. The mathematics of quality supersede the mathematics of quantity. 1 Type 91 torpedo is worth 3 American torpedoes. 1 Japanese pilot equals 5 American pilots. Your production statistics are meaningless without incorporating qualitative adjustments. Yamato attempted to explain that increasing American proficiency, demonstrated through improving hit rates and declining losses, suggested that training quality had improved alongside production quantity. The staff dismissed his analysis. Quantitative statistics without qualitative adjustment produced misleading conclusions. Japanese superiority in training, discipline, and combat spirit would offset American numerical advantages. Japanese naval tactics attempted multiple counters to improving American strike coordination. They increased CAP strength from 12 fighters to 24 fighters over major fleet concentrations. The Americans adapted by increasing fighter sweeps preceding strikes. Japanese forces positioned anti-aircraft cruisers in defensive screens around capital ships. The Americans adapted by assigning dedicated dive bombers to suppress AA cruisers during torpedo attacks. Japanese commanders attempted to maneuver into cloud cover when American formations appeared on radar. The Americans adapted by using radar-equipped strike coordinators to maintain target acquisition through weather. Japanese ships increased anti-aircraft ammunition loadouts by 40%. The Americans increased strike package sizes by 60%. March 18, 1945. Kure Naval Base, Japan, 13:15 hours. Yamato sortied with destroyer escort to engage American carrier task force approaching Kyushu. At 13:42 hours, radar detected 112 American aircraft at 95 kilometers, approaching in coordinated waves. Vice Admiral Fukuda, embarked aboard Yamato for this sortie, observed the formation with satisfaction. They commit large numbers because they know they will lose half their aircraft. Wasteful American tactics compensate for poor pilot training. At 13:48 hours, anti-aircraft batteries opened fire. At 13:49 hours plus 18 seconds, first American fighter destroyed. Kill time, 7 seconds. At 13:50 hours, first dive bomber destroyed. Kill time, 11 seconds. At 13:51 hours, first torpedo bomber destroyed. Kill time, 9 seconds. The engagement developed with unprecedented American coordination. Dive bombers attacked from 3,500 meters, releasing semi-armor-piercing bombs that targeted deck armor to suppress anti-aircraft positions. Torpedo bombers attacked from both sides simultaneously, splitting defensive fire. Fighters strafed anti-aircraft positions throughout the attack. At 13:54 hours, first torpedo struck port side, frame 125. Flooding contained to outer 2 protection layers. At 13:55 hours, second torpedo struck starboard side, frame 167. Flooding contained to outer protection layers. At 13:56 hours, third torpedo struck port side, frame 140. Flooding contained to outer 3 protection layers. The holding bulkhead sustained partial damage but prevented machinery space flooding. Total engagement duration, 18 minutes. Enemy losses, 18 aircraft destroyed. Kill ratio, 18-0. American losses, 54 aircrew. Japanese losses, 0 ships sunk. Yamato sustained 3 torpedo hits producing 540 tons of flooding, requiring dockyard repair estimated at 12 days, temporary speed reduction to 22 knots. The ammunition expended in this 18-minute engagement, totaling 19,400 rounds of 25mm ammunition, 520 rounds of 12.7 centimeter, and 280 rounds of 13.2mm, exceeded the monthly ammunition allocation to the entire combined fleet. Vice Admiral Fukuda remained confident. 3 hits from approximately 30 torpedoes launched. Their accuracy remains appalling. Our protection system contained all flooding. We remain combat effective. This engagement proves American numerical superiority cannot overcome Japanese technological and tactical superiority. Commander Yamato presented his final pre-battle intelligence assessment to Combined Fleet Headquarters on March 25, 1945. American carrier task forces now operate continuously within 500 kilometers of the home islands. Task Force 58 comprises 16 fleet carriers, 6 light carriers, total aircraft strength exceeding 1,400 aircraft. American strike packages routinely exceed 200 aircraft per target. American torpedo bomber crews demonstrate 65% hit rates, up from 15% in 1943. American coordination between torpedo, dive bomber, and fighter elements has achieved near-perfect timing. Most critically, American production now replaces losses faster than we can inflict them. Task Force 58 lost 137 aircraft last week. Task Force 58 received 158 replacement aircraft this week. We cannot achieve attrition faster than American replacement rates. The statistics were irrefutable. Japanese naval aviation had declined from 1,800 first-line aircraft in December 1941 to 340 first-line aircraft in March 1945. American carrier aviation had grown from 1,100 first-line aircraft to 9,400 first-line aircraft in the same period. The combined fleet staff acknowledged Yamato's report and ordered preparations for Operation Tengo. Vice Admiral Fukuda refused to accept Yamato's conclusions even with updated combat data. Mathematics that ignore fighting spirit produce defeatist conclusions. Yamato's protection system has contained every torpedo hit sustained across 3 engagements. The holding bulkheads have prevented critical flooding in every instance. Our sailors demonstrate superior discipline and damage control proficiency. American numerical advantages are meaningless if their torpedoes cannot sink our capital ships. I have personally observed our protection systems function exactly as designed under combat conditions. Commander Yamato's statistics reflect American industrial capacity, not combat effectiveness. Combat effectiveness derives from training, discipline, and fighting spirit, areas where we maintain absolute superiority. Lieutenant Sato observed that each successive engagement produced heavier flooding, despite the protection system containing damage to outer zones. The first engagement in November 1943 had produced 180 tons of flooding from one hit. The March 1945 engagement had produced 540 tons of flooding from 3 hits. The holding bulkheads were sustaining cumulative stress damage from repeated shock loading. Sato documented his observations in his damage control log. The structural engineers at Kure examined his report and concluded that the holding bulkheads were performing within acceptable stress parameters. Minor cracking in welded seams was normal under combat loading. The protection system retained full effectiveness. Production avalanche. At the Naval Air Station Pensacola Modification Facility, the Mark 13 torpedo assembly process achieved 17 completed weapons per 8-hour shift. Every 28 minutes, another modified torpedo rolled off the final inspection station. This single facility produced more aerial torpedoes in 1 month than the entire Japanese naval torpedo establishment produced in 3 months. The production line incorporated 47 specific modifications, addressing every identified failure mode from 30 months of combat experience. Workers installed strengthened nose assemblies that withstood 200-knot water entry impact without collapse. Wooden tail assemblies received waterproof coatings that prevented disintegration after water entry. The Mark 8 contact exploder replaced the defective Mark 6 magnetic mechanism, increasing reliability from 20% to 87%. Each torpedo underwent 3 separate electrical continuity tests, 4 mechanical function tests, and 2 complete operational checks before shipment. Quality acceptance rates exceeded 98%. Monthly production from this single facility was 510 torpedoes. Monthly production from Kure, Yokosuka, and Sasebo naval arsenals combined totaled 240 torpedoes. Americans discarded 17 torpedoes daily from final inspection rejects, minor cosmetic damage, or handling incidents that Japanese facilities would have repaired and reissued. Each discarded torpedo contained 270 kilograms of Torpex explosive, precision-machined aluminum body components, bronze propulsion fittings, and 840 meters of electrical wiring. The 17 torpedoes discarded daily represented more finished weapons than the Kure arsenal produced weekly. Japanese arsenals allocated explosive compounds by the gram. American facilities threw away 4,590 kilograms of torpedo explosive weekly from rejected weapons, weapons damaged in testing, and weapons that failed acceptance standards. This weekly waste exceeded the entire monthly explosive allocation to all 3 Japanese naval arsenals combined. Workers threw away wooden tail assemblies showing minor warping or cosmetic defects. Japanese craftsmen received specific orders to repair and reuse every wooden component regardless of damage severity. American workers threw away more wooden components daily than Japan, allocated monthly to the Sasebo arsenal. The waste from single-shift tail assembly rejection, measured at 23 tail assemblies discarded for minor defects, exceeded Japan's weekly production of replacement tail assemblies. The cafeteria at the Pensacola facility discarded 180 kilograms of food daily from uneaten meals, spoiled inventory, and preparation waste. This daily waste exceeded the monthly protein allocation to the entire Kure Naval Arsenal's 12,000 personnel. Workers threw away beef, pork, chicken, and fish that Japanese naval stations rationed at 40 grams per person daily. The cafeteria discarded more meat in 1 week than the Yokosuka Naval Station received monthly. Cafeteria workers threw away bread showing minor staleness. Japanese naval personnel received 120 grams of rice daily as the staple food allocation. The bread waste from 1 day at Pensacola, measured at 67 kilograms, represented more grain than a Japanese destroyer crew of 240 men received weekly. Aluminum scrap from rejected torpedo body sections totaled 890 kilograms daily. Each rejected body section was machined from solid aluminum stock, required 47 hours of precision machining across 12 separate operations, and was discarded for defects as minor as surface scratches, slight dimensional deviations, or cosmetic imperfections. Japanese industry allocated aluminum by the gram, prioritizing aircraft production over all other uses. The daily aluminum scrap from Pensacola's torpedo facility could have built 17 Japanese aircraft. The weekly aluminum waste, measured at 6,230 kilograms, exceeded the monthly aluminum allocation to the Mitsubishi A6M0 production facility at Nagoya. American facilities threw away more aluminum in 1 week than Japan allocated monthly to its primary fighter production plant. This single aspect of torpedo production waste exceeded entire Japanese aluminum allocation for naval aviation manufacturing. Discarded ammunition from torpedo testing and acceptance firing exceeded Japanese combat allocation across the entire combined fleet. Each finished torpedo underwent live fire testing to verify propulsion, depth keeping, and straight-running performance. Torpedoes that failed any acceptance test were discarded rather than repaired. Daily testing consumed 8 torpedoes firing into test nets and barriers. These 8 torpedoes, representing 2,160 kilograms of explosive and complete weapon systems, exceeded the weekly torpedo allocation to the entire Japanese submarine force. Testing waste from 1 week at Pensacola exceeded the monthly combat torpedo allocation to Japanese naval aviation across all air groups, all bases, and all carriers. American facilities tested and discarded more torpedoes monthly than Japanese forces fired in combat quarterly. Commander Yamato compiled production statistics for his March 1945 intelligence summary. American torpedo production from all facilities, 1,240 torpedoes monthly. Japanese torpedo production from all arsenals, 240 torpedoes monthly. American torpedo bomber production, 620 aircraft monthly. Japanese torpedo bomber production, 87 aircraft monthly. American carrier production, 2.5 fleet carriers commissioned monthly since January 1943. Japanese carrier production, 0 carriers commissioned since September 1944. A single American shipyard, Newport News, was constructing 3 Essex-class carriers simultaneously, each displacing 27,000 tons, each requiring 18 months from keel laying to commissioning. Japan's entire remaining shipbuilding capacity was producing destroyers and escorts. This single aspect of American naval production, carrier construction at one shipyard, exceeded Japan's entire capital ship construction program. Systematic annihilation. April 7, 1945. Operation Tengo, East China Sea 12-20 hours. Yamato sortied from Tokuyama with destroyer escort on one-way mission to beach on Okinawa and serve as shore battery supporting island defense. The battleship carried fuel for one-way transit, ammunition for sustained shore bombardment, and minimal provisions. At 12:20 hours, radar detected 386 American aircraft approaching from multiple carrier task groups. The formation consisted of 180 fighters, 75 dive bombers, and 131 torpedo bombers. Yamato faced the largest concentrated airstrike launched against a single naval target in military history. At 12:32 hours, anti-aircraft batteries opened fire at maximum range. At 12:34 hours plus 12 seconds, first American aircraft destroyed at 4,200 meters. Kill time, 8 seconds. At 12:35 hours, second aircraft destroyed. Kill time, 11 seconds. At 12:36 hours, third aircraft destroyed. Kill time, 9 seconds. The defensive barrage achieved initial success against leading elements. At 12:40 hours, American Strike Coordinator ordered simultaneous attack from all quadrants. Torpedo bombers attacked from port, starboard, bow, and stern simultaneously. Dive bombers attacked from directly overhead. Fighters suppressed anti-aircraft positions through continuous strafing. Yamato's defensive fire, previously concentrated on single attack axes, now distributed across 360-degree threat envelope. At 12:41 hours, first torpedo struck port side, frame 130. Flooding contained to outer protection zones. At 12:42 hours, second torpedo struck starboard side, frame 158. Flooding contained to outer zones. At 12:43 hours, third and fourth torpedoes struck port side, frames 118 and 142 within 8 seconds of each other. The simultaneous detonations overwhelmed the protection system's blast dissipation capability. The holding bulkhead ruptured along welded seams between frames 120-145. Seawater flooded into machinery spaces. At 12:44 hours, fifth torpedo struck port side, frame 105. The impact enlarged the existing holding bulkhead failure. Flooding increased to 3,000 tons. Yamato developed 12-degree list to port. At 12:45 hours, sixth torpedo struck port side, frame 95. At 12:46 hours, seventh and eighth torpedoes struck port side, frames 87 and 152. The cumulative flooding exceeded damage control capacity. List increased to 18 degrees. Counterflooding to correct list produced additional 2,400 tons of water aboard. At 12:47 hours, ninth torpedo struck port side, frame 62. At 12:48 hours, 10th torpedo struck port side, frame 178. At 12:49 hours, 11th torpedo struck port side, frame 136. Total torpedo hits, 11 all port side. The concentration of impacts on a single side prevented effective counterflooding. The holding bulkhead, designed to contain individual torpedo detonations, ruptured completely under concentrated multiple simultaneous impacts. Total engagement duration, 28 minutes. Enemy aircraft destroyed, 10 aircraft. Kill ratio, 10-0 achieved against attacking force but irrelevant given Yamato sinking. American losses, 30 aircrew. Japanese losses, Yamato sinking 3,055 dead, 276 survivors. The kill ratio measured in aircraft destroyed was 10-0. The kill ratio measured in strategic outcome was 0-1, complete American victory. The ammunition expended defending against this attack. Approximately 18,000 rounds of 25 mm, 1,100 rounds of 12.7 cm, and 450 rounds of 13.2 mm, exceeded the remaining ammunition allocation to the entire combined fleet for April 1945. The fuel consumed by American aircraft conducting this strike, approximately 168,000 liters of aviation gasoline, exceeded the monthly aviation fuel allocation to Japanese naval aviation across all remaining air groups. At 14:05 hours, Yamato capsized to port and sank. At 14:07 hours, forward magazines detonated, sending a mushroom cloud visible from 150 kilometers. The battleship that was designed to withstand 400-kilogram warhead detonations in direct contact had been destroyed by 11 270-kilogram torpedoes, none of which had penetrated the outer hull as individual impacts. The protection system functioned exactly as designed against individual hits. The protection system failed catastrophically when subjected to concentrated multiple hits along a single axis within compressed time period. The holding bulkheads ruptured under cumulative shock, loading from impacts occurring within seconds of each other. The design had anticipated distributed hits over extended engagement duration, allowing damage control between impacts. The American strike had delivered concentrated hits faster than damage control could respond. Vice Admiral Fukuda died aboard Yamato at 14:05 hours when the battleship capsized. At 14:03 hours, 2 minutes before capsizing, Fukuda had been observed on the bridge directing damage control efforts, attempting to establish counterflooding to correct the list. At 14:04 hours, the list increased beyond recoverable angles. At 14:05 hours, Yamato rolled completely inverted. Elapsed time from first torpedo hit to sinking, 144 minutes, 32 seconds. Fukuda had expressed confidence in the protection system through the first 5 torpedo hits. The 6th hit had introduced doubt. The 8th hit had prompted orders to abandon ship for non-essential personnel. The 10th hit had made sinking inevitable. Lieutenant Sato survived. He had been directing damage control teams in the starboard aft compartments when the final torpedoes struck. The rapid list to port had trapped him in a rising air pocket as compartments flooded. He had escaped through an access trunk as Yamato capsized, swimming clear as the ship rolled completely over. He was recovered by destroyer Yukikaze 3 hours later, one of 276 survivors from a crew of 3,332. Sato observed in his survival report that the holding bulkheads had contained flooding from the first 2 torpedo hits. The 3rd and 4th simultaneous hits had initiated the catastrophic failure. The protection system, designed for sequential hits with time intervals allowing damage control response, had been overwhelmed by simultaneous impacts that produced cumulative shock loading beyond design parameters. An unnamed surviving petty officer stated during post-battle interrogation, "This wasn't combat. This was systematic annihilation. They came from every direction at once. We shot down aircraft continuously, but more kept coming. When one torpedo hit, we contained it. When two hit simultaneously, we struggled to contain them. When four hit within seconds, we lost containment. When 8 hits accumulated within minutes, the ship died. They didn't outfight us. They buried us under numbers." Capitulation testimonies. August 1945, Amori Interrogation Center, Tokyo. Commander Yamato Takeishi provided detailed testimony to American naval intelligence officers regarding Japanese torpedo defense systems and the specific failure modes that resulted in Yamato's loss. "We were not defeated by better soldiers, but by better factories. American torpedo production reached 1,240 weapons monthly by early 1945. Japanese production totaled 240 weapons monthly. A single American facility at Pensacola produced more aerial torpedoes than our 3 primary naval arsenals combined. The mathematics were absolute. We could not replace losses. You replaced losses faster than we could inflict them. We calculated kill ratios. You calculated replacement rates. Your replacement rates exceeded our best possible attrition rates by factors of 3 to 5 depending on aircraft type." Yamato detailed production comparisons documented through his intelligence assessments. At peak efficiency, Kure Arsenal produced 87 torpedoes monthly. Pensacola produced 510 torpedoes monthly from a single modification facility. One American facility exceeded our largest arsenal by factor of 5. 9. 1. Your Newport News shipyard constructed 3 fleet carriers simultaneously. Our entire remaining shipbuilding capacity was producing destroyers and coastal escorts. A single American yard was building more carrier tonnage than our entire industry. You produced 620 torpedo bombers monthly. We produced 87 torpedo bombers monthly. You outproduced us in every category by minimum factors of 5, 1, reaching factors of 12, 1 in some categories." Lieutenant Sato provided technical testimony regarding Yamato's protection system performance and failure modes. The holding bulkheads were designed to withstand 400-kilogram warhead detonations from individual torpedo hits with sufficient time intervals for damage control response between impacts. The design calculations were mathematically sound for sequential engagement scenarios. The design failed when subjected to concentrated simultaneous impacts along a single axis. The first 2 hits on April 7 were contained successfully. Hits 3 and 4 struck within 8 seconds of each other. The simultaneous blast propagation through liquid layers overwhelmed the holding bulkhead's dissipation capacity. The welded seams ruptured between frames 120-145. Once the holding bulkhead failed, subsequent hits flooded directly into machinery spaces. The protection system functioned as designed against sequential hits. The system failed against concentrated simultaneous hits delivered faster than damage control could respond. The Americans didn't revolutionize torpedo technology. They revolutionized torpedo delivery coordination. They attacked from all axes simultaneously with sufficient numbers to guarantee multiple simultaneous impacts regardless of defensive fire effectiveness. A surviving junior officer from Yamato's engineering section testified, "We brought medieval fortress design principles to industrialized warfare. Our protection system was a castle, layers of walls and moats designed to stop individual siege engines. The Americans brought assembly line methodology to aerial attack. They didn't need better siege engines. They brought 386 siege engines simultaneously. Our castle walls held against the first few engines. The walls crumbled when hit by dozens of engines striking the same spot within seconds. Their excess strike capacity exceeded our maximum defensive effort. We shot down 10% of attacking aircraft. They still delivered 11 torpedo hits. Their acceptable loss rates exceeded our maximum defensive capability." Additional testimony from surviving destroyer captains included consistent observations. "They coordinated 3-axis attacks with precision we couldn't match. Dive bombers suppressed anti-aircraft positions exactly as torpedo bombers approached release points. Fighters strafed gun crews exactly as dive bombers rolled in. Every element supported every other element with factory precision timing. This wasn't individual pilot skill. This was systematic training producing consistent, standardized coordination. They could lose half their aircraft and still achieve mission objectives. Their excess capacity exceeded our ability to inflict attrition. A senior naval constructor from Kure Arsenal testified regarding Japanese industrial limitations. We could not produce torpedoes faster than approximately 240 monthly from all arsenals combined due to explosive compound supply limitations, aluminum allocation priorities favoring aircraft production, and precision machining capacity constraints. American facilities produced 5 times our output while simultaneously throwing away more material than we allocated to production. They discarded 890 kilograms of aluminum daily from rejected torpedo components. We allocated 840 kilograms of aluminum monthly to Kure Arsenal's entire torpedo production program. Their waste exceeded our allocation. This single comparison reveals the industrial gulf we faced. Statistics stated by surviving combined fleet staff officers during interrogation. American torpedo production, all facilities combined, peaked at 1,240 torpedoes monthly. Japanese production across all arsenals totaled 240 torpedoes monthly. Single American facility at Pensacola, 510 torpedoes monthly. Entire Japanese naval arsenal system, 240 torpedoes monthly. American carrier aviation strength, March 1945, 9,400 first-line aircraft. Japanese carrier aviation strength, March 1945, 340 first-line aircraft. American replacement rates exceeded attrition rates by factor of 1.31. Japanese losses exceeded replacement capacity by factor of 4.1. We faced mathematical extinction regardless of tactical performance. Philosophical coda. The Mark 13 torpedo proved that democratic industrial systems could outproduce authoritarian command economies through systematic application of assembly line methodology, statistical quality control, and iterative improvement processes. Free workers at Pensacola outproduced impressed laborers at Kure by ratios exceeding 5:1 per capita. Democratic cooperation between Navy pilots, civilian engineers, and industrial workers exceeded totalitarian command structure effectiveness by enabling bottom-up problem identification and rapid solution implementation. Industrial abundance buried ideological superiority under 1,240 torpedoes monthly, 620 aircraft monthly, and 386 aircraft in a single strike. The mathematics were absolute. American workers producing 8.7 torpedoes per worker monthly exceeded Japanese workers producing 1.2 torpedoes per worker monthly by ratio of 7:25:1. This productivity differential, replicated across every industrial category, guaranteed Japanese defeat regardless of tactical innovations or operational excellence. Yamato's underwater protection represented sophisticated engineering solving the wrong problem. The design successfully contained individual torpedo hits. The design failed against concentrated multiple simultaneous hits delivered by industrialized aerial warfare. Japanese engineers had designed a system to defeat the torpedo. American industry had created a system to deliver torpedoes in quantities that overwhelmed any defensive system. The contest between sophisticated protection and mass delivery was settled by American industry producing 5,169 torpedoes per year against Japanese production of 2,880 torpedoes per year. Superior engineering was buried under superior production. March 12, 1941. Vice Admiral Fukuda Keiji had examined Yamato's protection system blueprints with absolute confidence. "The mathematics are undeniable," he had said, dismissing Commander Yamato's warnings. April 7, 1945. Fukuda died aboard Yamato as the battleship capsized from flooding that overwhelmed protection systems designed to contain exactly the torpedo damage that destroyed the ship. The protection system functioned exactly as designed against sequential hits. American industry delivered simultaneous hits faster than any design could contain. Fukuda's mockery of American industrial capacity became history's most expensive miscalculation. The miscalculation cost 3,055 lives, one battleship representing 72,000 tons of scarce steel and 50,000 man-years of construction labor, and any remaining Japanese confidence in technological superiority compensating for industrial inferiority. September 2, 1945. USS Missouri, Tokyo Bay. Commander Yamato Takeshi stood with the Japanese surrender delegation on the deck of the American battleship, his white dress uniform pressed despite 4 months of food shortages that had reduced his weight by 18 kilograms. Around him, representatives of the combined fleet that no longer existed prepared to sign instruments of unconditional surrender. Yamato observed the American sailors manning the deck. Their uniforms fit properly. Their faces showed adequate nutrition. The ship itself, commissioned in June 1944, represented construction capacity that Japan had lost in 1943. Missouri displaced 45,000 tons. Japan's entire 1945 steel production totaled 380,000 tons. This single American battleship represented 11.8% of Japan's total annual steel output. The Americans had commissioned 4 Iowa-class battleships while simultaneously producing 141 Essex-class fleet carriers, 1,200 destroyers and destroyer escorts, and 1,400 landing ships. Yamato's pre-war intelligence assessments had documented this production capacity. The Naval General Staff had dismissed his reports as statistically improbable. Lieutenant Sato Kenji, standing in the third row of junior officers, still experienced nightmares about the capsizing. 4 months had not diminished the memory of Yamato rolling to port, the holding bulkheads rupturing along welded seams, seawater flooding into machinery spaces faster than pumps could compensate. He had written detailed technical reports on the protection system's failure modes. The reports documented that the design had functioned perfectly against individual sequential hits. The design had failed against concentrated simultaneous impacts delivered within seconds of each other. American strike coordination had overwhelmed Japanese engineering through systematic application of superior numbers precisely timed. Sato calculated that defending against the April 7 attack would have required anti-aircraft firepower exceeding Yamato's maximum capacity by factor of 4. 1. No ship could mount sufficient defensive armament. The Americans had simply brought more aircraft than any defense could stop. General MacArthur read the surrender terms. The ceremony lasted 23 minutes. Japan formally acknowledged defeat to military forces that had outproduced Japanese industry by ratios ranging from 5:1 in basic categories to 20:1 in advanced weapon systems. American industrial production in 1944 had totaled $234 billion. Japanese industrial production in 1944 had totaled $24 billion. The disparity was 9:75:1. This ratio had remained consistent across specific categories: aircraft production 9:2:1, naval vessel tonnage 11:4:1, steel production 8:9:1, aluminum production 14:6:1. Vice Admiral Fukuda had dismissed these statistics as irrelevant compared to Japanese fighting spirit and tactical excellence. Fukuda's body remained in Yamato's wreckage 340 meters below the East China Sea surface. October 1945. Strategic Bombing Survey Interrogation Center, Yokohama. American analysts questioned Commander Yamato regarding Japanese intelligence assessment methodology and why warnings about American production capacity had been systematically dismissed. Yamato provided frank testimony. Our intelligence collection was adequate. Our intelligence assessment was catastrophically flawed. I documented in February 1943 that American Liberty ship production reached 140 vessels monthly. The Naval General Staff adjusted my assessment by a quality factor of 0.4, concluding that American ships were inferior and should be counted as 56 quality equivalent vessels. I documented that Grumman produced 550 Avenger torpedo bombers monthly. The staff applied a pilot quality adjustment factor of 0.25, concluding that only 137 aircraft represented real combat capability. Every quantitative assessment I submitted was adjusted downward by subjective quality factors. The adjusted numbers supported existing strategic assumptions. The unadjusted numbers predicted defeat. The staff chose to believe the adjusted numbers. Yamato detailed specific intelligence failures. I reported in April 1944 that American torpedo reliability had improved from 20% to 85% through systematic testing and modification. The staff dismissed this as impossible given American industrial disorganization. I reported in September 1944 that American carrier task forces were conducting 200-plus aircraft strikes with near-perfect coordination. The staff explained this was temporary luck, not systematic training improvement. I reported in January 1945 that Task Force 58 was replacing losses faster than we could inflict them. The staff stated this violated the mathematics of attrition warfare and must represent false intelligence. Every report that contradicted our strategic assumptions was dismissed as either false intelligence or temporary statistical anomaly. American interrogators asked why Japanese leadership had committed Yamato to Operation Tengo knowing American carrier strength made the mission suicidal. Yamato responded with uncomfortable honesty. Because we had no other options. Yamato consumed 400 tons of fuel oil daily at operational speeds. We possessed 2,700 tons of fuel oil total in reserve. We could operate Yamato for 6 days, or we could allow the fuel to be destroyed when American forces invaded. The mission was suicide because every remaining option was suicide. We had lost the mathematics of logistics before we lost the mathematics of combat. A navy without fuel cannot fight regardless of ship design excellence. November 1945, Kure Naval Arsenal Demolition Site. Lieutenant Sato supervised the technical inspection team documenting Yamato's sister ship, Musashi's construction records before the arsenal's demolition under surrender terms. The records revealed that Musashi had consumed 57,000 man-years of labor from keel laying to commissioning. This represented more labor than American shipyards expended building 4 Essex-class carriers. The construction timeline had been 35 months. American yards commissioned Essex-class carriers in 18 months. Yamato-class construction had consumed resources that could have built 16 destroyers or 8 cruisers per battleship. The resource allocation had prioritized individual ship superiority over fleet numerical strength. This decision had produced 2 battleships with excellent protection systems. The decision had prevented construction of 32 destroyers that might have provided convoy escort, preventing merchant ship losses exceeding 8 million tons. Sato examined the holding bulkhead design specifications. The 75mm hardened steel plates had been manufactured to tolerances of 0.3 millimeters across 180 square meters of surface area. Japanese steel mills had required 4 months to produce bulkhead plates meeting these specifications. American yards used 50mm bulkhead plates manufactured to 1.2 millimeter tolerances, produced in 3 weeks. The Japanese bulkheads provided 50% greater blast resistance. The American bulkheads were produced 5.3 times faster. When Yamato faced 386 American aircraft, the superior bulkhead blast resistance was irrelevant. The Americans delivered more torpedoes than any bulkhead thickness could stop. Japan had optimized for quality per unit. America had optimized for units produced. The mathematics favored units produced. The arsenal demolition proceeded systematically. American engineers supervised removal of machine tools, precision instruments, and manufacturing equipment that would be destroyed or shipped to Allied nations as reparations. The torpedo production facility had produced 87 torpedoes monthly at peak capacity. The facility had employed 1,240 workers operating 2 12-hour shifts. Per capita productivity was 0.07 torpedoes per worker monthly. The Pensacola facility had produced 510 torpedoes monthly employing 1,180 workers operating 3 8-hour shifts. Per capita productivity was 0.43 torpedoes per worker monthly. American workers outproduced Japanese workers 1 while working 8-hour shifts compared to 12-hour shifts. The productivity differential reflected systematic differences in training, tool quality, supply chain reliability, and workplace safety. Exhausted workers operating inadequate equipment with interrupted supply chains could not match well-rested workers operating modern equipment with reliable supply chains regardless of fighting spirit or national dedication. December 1945, War Crimes Tribunal Preparation, Tokyo. Commander Yamada provided testimony regarding Japanese decision-making processes that had led to Operation Tengo. The mission was ordered knowing it was suicide. We possessed insufficient fuel for return voyage. We loaded ammunition for shore bombardment we would never conduct. We assigned 3,332 crew to a mission with 0 probability of success. This was not a military operation. This was ritual suicide on industrial scale. The mathematics demonstrated impossibility before the operation commenced. We calculated American carrier strength at 22 carriers, 1,400 plus aircraft. We calculated our defensive firepower could engage approximately 80 aircraft simultaneously with lethal effect. We knew they would bring 300-plus aircraft. The numbers proved the operation would fail before ships departed port. Interrogators asked why the operation proceeded given clear impossibility of success. Yamato explained the psychology of defeat. Because acknowledging the mathematics meant acknowledging that our entire strategic framework had been catastrophically wrong. Acknowledging that one American factory outproduced our entire arsenal system meant acknowledging that our pre-war assumptions about American industrial weakness had been fantasy. The leadership chose death over acknowledging error. 3,000 men died because admirals could not admit they had miscalculated American productive capacity by factors of 10. Vice Admiral Fukuda died believing the protection system had been overwhelmed by temporary bad luck, not systematic American numerical superiority. He died without accepting that his fundamental assumptions about warfare had been obsolete since 1943. January 1946, Osaka University, Department of Naval Architecture. Lieutenant Sato accepted a faculty position teaching marine engineering. His first lecture addressed 73 students, many of whom were former naval personnel transitioning to civilian careers. Sato presented the technical analysis of Yamato's protection system failure. The design was excellent for the war we expected to fight. The design failed for the war we actually fought. We expected individual torpedo hits with time intervals allowing damage control response. We designed bulkheads to contain sequential hits. We encountered simultaneous multiple hits delivered faster than damage control could respond. Our error was not in engineering calculation. Our error was in strategic assumption. We assumed enemies would attack individually with weapons we could count and defend against. We failed to consider enemies who could deliver weapons in quantities that overwhelmed any possible defense. Sato displayed production statistics. American torpedo production, 1,240 monthly. Japanese production, 240 monthly. When your enemy produces 5 times more weapons, you cannot build defenses thick enough. You can only produce more ships dispersing their targeting. We built 2 Yamato-class battleships with excellent protection. We should have built 16 destroyers with adequate protection. The 16 destroyers would have provided convoy escort, preventing merchant losses that starved our industry of raw materials. The 2 battleships provided symbolic superiority that contributed nothing to strategic victory. We optimized for individual excellence. We should have optimized for systemic resilience. The mathematics proved this by April 1945. We chose to ignore the mathematics until mathematics killed 3,055 men in 28 minutes. The students, many of whom had served aboard ships that had been sunk by overwhelming American aerial attacks, listened with uncomfortable recognition. Sato continued. The lesson for future engineers is this: technical excellence is meaningless without strategic context. Yamato's protection system was technically excellent. Strategically, the protection system was irrelevant because the Americans brought more aircraft than any protection could stop. Future naval architects must design for the war that logistics and production make possible, not the war that tactical theory prefers. The enemy who can build more ships, train more pilots, and deliver more weapons will win regardless of individual platform superiority. Design for mass production and systemic resilience, not individual excellence and symbolic superiority. April 7, 1946. First Anniversary Memorial Service, Yokosuka. 276 survivors gathered at the Naval Chapel for memorial service honoring 3,055 dead from Yamato's sinking. Commander Yamato delivered the keynote address. We honor men who died following orders they knew were suicide. We honor sailors who fought a protection system's failure they could not prevent. We honor warriors who faced mathematical impossibility with discipline and courage. But we must also acknowledge what killed them. They died because our leadership dismissed intelligence reports documenting American production capacity. They died because our strategic planning applied subjective quality adjustments to objective quantitative data. They died because we chose to believe comforting assumptions instead of uncomfortable mathematics. Yamato detailed the intelligence failures that had led to Operation Tengo. I reported in March 1945 that Task Force 58 comprised 1,400-plus aircraft. The combined fleet staff acknowledged my report and ordered Yamato to sortie with destroyer escort. The mathematics demonstrated that 8 destroyers and 1 battleship could not defend against 1,400 aircraft. The staff ordered the operation anyway because the alternative was acknowledging total defeat. 3,000 men died because admirals chose symbolic action over mathematical reality. This was not honorable death in combat. This was waste of human life to avoid acknowledging error. Lieutenant Sato spoke, representing the 276 survivors. I supervised damage control aboard Yamato for 18 months. I conducted flooding drills across 400 compartments. I verified the protection system functioned exactly as designed. The protection system contained the first 2 torpedo hits on April 7. The system failed when hits 3 and 4 struck simultaneously. The system was overwhelmed when 11 hits accumulated within 8 minutes. The Americans did not defeat our protection system through better torpedoes. They defeated our protection system through better production. They brought 386 aircraft. We could not shoot down 386 aircraft. The mathematics were absolute. My damage control training was excellent. My damage control capacity was irrelevant when facing attacks exceeding our defensive capacity by factor of 4. We died because our industrial capacity could not build sufficient ships to disperse American targeting, and because our production capacity could not build sufficient ammunition to defend against American numbers. The memorial service concluded with reading the names of all 3,055 dead. The reading required 48 minutes. The Americans had destroyed Yamato in 28 minutes. The mathematics remained absolute even in memorial. The battleship designed to survive any attack had been destroyed by attacks delivered in quantities exceeding any defense. The lesson was permanent. Industrial production capacity determines military outcomes regardless of tactical excellence or individual weapon superiority. Vice Admiral Fukuda had understood mathematics. He had calculated the wrong variables. He should have counted factories instead of armor thickness. The mathematics of production exceeded the mathematics of protection. That lesson, written in 3,055 deaths, remained Japan's most expensive education in modern warfare's fundamental principle. The side that can produce more weapons and deliver them more reliably wins regardless of individual platform sophistication.